So a circle is there. We are going to actually now, first of all, we are going to see the concept of chord and tangent and secant. What is a secant? What is a tangent? This we are going to see. So in figure 10.1, suppose PQ is a line and circle and line has no point in common. In this case, PQ is called non-intersecting line. PQ and circle have no point in common. So this is a case of non-intersecting line. In this was the case of non-intersecting line. In second case, the line is intersecting circle at 2 points. The line is intersecting circle at 2 points. This type of line is called secant of the circle. Secant of the circle. Okay. Now, in third case, this one, the line is intersecting the circle at exactly 1 point. This is called tangent. Tangent to a circle intersects the circle at only 1 point. Okay. So this is non-intersecting line. This is the line intersecting the circle at 2 points. Okay. So these are A and B are 2 points. This is called secant and this is called tangent. Tangent is a line which intersects the circle at exactly 1 point. Okay. Now, so definition: a tangent to a circle is a line that intersects the circle at only 1 point. Okay. Now, if I locate any one point on the circle, okay, how many tangents can pass through this point? Only one tangent can pass through a single point on the circle. कोई भी एक single point है, तो वहां से सिर्फ एक tangent pass हो सकती है. Okay, so nearby that point, next only one tangent. हर point से सिर्फ एक tangent pass हो सकती है. So there is only one tangent at a point of the circle. Okay. Tangent to a circle is a special case of secant where the two endpoints of the corresponding chord coincides. अब ये जो secant है इसमें दो पॉइंट्स हैं A और B. अगर ये दोनों पॉइंट एक सिंगल पॉइंट बन जाए, दोनों पॉइंट अगर कॉन्साइड करें, तो दैट इज द केस ऑफ tangent. Okay, so tangent is a special case of secant. Basically, it is saying. Okay, now the common point of tangent and circle is called point of contact, and the tangent is said to touch the circle at only one common point. That common point is called point of contact. So this is the point of contact where tangent touches the circle. Okay. Now theorem 10.1. Tangent at any point of the circle is perpendicular to the radius through the point of contact. तो जो tangent to a circle है वो हमेशा perpendicular to the radius होगी at point of contact. Okay, so tangent at any point on the circle is perpendicular to the radius at the point of contact. Okay. If you want to do this derivation, so take, you can derive this or you can prove this theorem this way. Take a point P. Basically, first of all, draw a circle. Join OP. Suppose OP is radius. Construct a line XY such that it touches the circle at only one point P. Okay. Now take a point Q on this line. Okay. We can see OP is radius and OQ is slightly greater than radius. Okay. So OQ is greater than OP because ये है इसकी रेडियस, तो ये इस रेडियस से ज्यादा है, इसलिए OQ is greater than OP. Okay. Now from O to line XY, we can draw many lines. Okay, we can draw many lines, but we know that distance of a line and point always perpendicular distance is the shortest. That means OP will be the shortest distance between this point O and XY. Okay, so tangent at any point on the circle is perpendicular to the radius through point of contact. So this radius will be perpendicular to the tangent because जो shortest distance होगा वो हमेशा perpendicular का ही होगा. तो OP is perpendicular to XY. Now, based on this theorem and based on the concept of tangent, some questions are given that we are going to do. So exercise 10.1. Yes.
Ma'am, I joined late. So, ma'am, can you recall, but ma'am, a short recall of
Question number 1. How many tangents can a circle have? कोई सर्कल है तो उस पे कितनी टेंजेंट्स हो सकती है?
ma'am, infinite.
Yes, finite, because there are infinite points on the circle. So through this all points we can draw one tangent. So there will be infinite tangents. Fill in the blanks. The tangent to the circle intersects it at how many points? Tangent circle 1. So 1 will be the answer. Line intersecting a circle in 2 points is called?
Second.
Yes, secant.
Right.
Okay. Then a circle can have how many parallel tangents?
2.
Yes. Yes. Because suppose one tangent I have already drawn. अब इसके पैरेलल कितनी tangents होंगी? तो tangents सिर्फ एक पॉइंट पे यहाँ पे इसके पैरेलल होंगी. Okay. So 2 parallel tangents. The common point of a tangent to a circle and circle is called
Point of contact.
Point of contact. Okay. Now, next question, a tangent PQ at point P of a circle of radius 5 centimeter meets a line through center at Q so that OQ is 12, length PQ is. So basically figure is this only. ठीक है. अब यहाँ पे बोल रहा है tangent PQ है at point P of the circle of radius 5 centimeter, this is 5, meets a line through the center at a point Q. OQ is 12. We have to find PQ. Okay. We know this is 90 degree. Okay. So by applying Pythagoras theorem, 5 square plus PQ square equals to 12.
12 square equals to होगा ना. Sorry, ma'am.
तो 12 है ना. So PQ square will be equal to 12 square minus 5 square. This you can solve 12 minus 5. That is equal to 7. 12 plus 5, 17. So this will be 17 into 7. 7 sevens are 49. 4. 7 ones are 7. Plus 4, 11. 119. So
Seven.
will be under root 119. Okay. Any doubt till here? So this is the D is the correct answer. Okay. Now draw a circle and 2 lines parallel to given line such that one is tangent and other is secant to the circle. So you have to make a circle. One line you have to make secant and one you have to make tangent. And this should be parallel. Okay. So this is easy. I don't think this type of question will be asked. Fourth one you can do for your just to like memorize the concept, but it's not much important from examination point of view. Suppose a circle is there. A point P is lying inside the circle. How many tangents can pass through P?
Infinite.
Tangents pass through P.
अच्छा ऐसे 1
P से तो कोई भी tangent पास नहीं होगी, क्योंकि अगर ये कोई भी हम लाइन P से पास करेंगे तो वो सर्कल को एक पॉइंट पे इंटरसेक्ट करे, ऐसा हो ही नहीं सकता. Okay, so no tangent can pass if a point lies inside the circle. ठीक है? If a point lies inside the circle, there is no tangent which can pass through it. Yes, Nirviksha, are you raising hand?
Yes, ma'am.
Yes, बोलो.
Ma'am, but tangent तो ma'am सारी जगह वो
There is no tangent to the circle passing through a point lying inside the circle. If a point is lying inside the circle, there cannot be any tangent which is passing through it. If a point is lying on the circle, okay, there is only one and only one tangent that can pass through it. अगर point circle के ऊपर है तो उससे पास होने वाली सिर्फ एक tangent हो सकती है. If a point is lying outside the circle, यहाँ पे lie कर रहा है, तो इस point से पास होने वाली 2 tangents हो सकती है. Okay, if a point is lying outside the circle, then exactly 2 tangents can be there which can pass through this point. Clear है?
Yes, ma'am.
Now, अब यहाँ पे अगर हम इस वाले केस में देखें तो P से T1 और P से T2, ठीक है, इनको बोलते हैं लेंथ ऑफ tangent फ्रॉम पॉइंट P. PT1 is called length of tangent from point P. PT2 is also called length of tangent from point P. Okay, so PT1 and PT2 are length of tangents from point P to the circle. Okay, now next theorem is the length of tangents drawn from an external point to a circle are equal. अगर कोई एक्सटर्नल पॉइंट है, यहां से अगर दो टैंजेंट्स बनाई, ओके, तो ये जो लेंथ ऑफ टैंजेंट्स है ये हमेशा इक्वल होगी. लेंथ ऑफ टैंजेंट्स ड्रॉन फ्रॉम एन एक्सटर्नल पॉइंट टू अ सर्कल आर इक्वल. ओके, इफ यू वांट टू प्रूव दिस, we'll just join this P with the center of the circle. We'll join this and join this. Now in these two triangles we are going to prove congruent actually. Okay, we know that tangent is perpendicular to the radius. Okay, so this is 90 degree, this is also 90 degree, radius is already equal and this is common. Okay, so which congruence rule?
Angle, side angle.
No, right angle
RHS, sorry, RHS.
inside RHS. Okay, so RHS is the congruence rule, and because of that these two triangles will be congruent, and by CPCT PQ will be equal to PR. This is an important proof, everybody should know this. This can come in 2 mark. Prove that in two concentric circles the chord of the larger circle which touches the smaller circle is bisected at the point of contact. Okay, so concentric circles means center of both the circles are at the same point. Okay, we have to prove that the chord of larger circle जो C1 है उसकी जो chord है AB ये bisect हो रही है at the point of contact. मतलब we have to prove that AP equals to PB, ये हमको prove करना है. Okay, to prove. Now, okay, so now actually perpendicular from the center bisects the chord. Okay, so AB is a tangent and OP is radius for circle C2. C2 के लिए AB तो tangent है और OP radius है. ठीक है, तो OP will be perpendicular to AB. और हमने 9th क्लास में एक थियरम पढ़ा था, perpendicular from the center bisects the chord. ओके, तो मतलब अगर OP AB के परपेंडिकुलर है तो वो AP को बाइसेक्ट भी करेगा, तो AP इक्वल्स टू PB. तो एक्सरसाइज 10.2, फ्रॉम ए पॉइंट Q the length of tangent to the circle is 24. Okay, and distance of Q from the center is this, the radius of the circle is. Okay, so first thing you should make the figure. So figure will be this way, एक point Q लेना है, वहां से लेंथ ऑफ टेंजेंट है 24, वो एक एक्सटर्नल पॉइंट है, वहां से एक टेंजेंट बनाओ, वहां से टेंजेंट की लेंथ है 24. ठीक है, इस पॉइंट Q को सेंटर से ज्वाइन करना है और सेंटर से उसका डिस्टेंस है 25. वी हैव टू फाइंड द रेडियस ऑफ द सर्कल. So this will be 90 degree because tangent and radius will form 90 degree. So now in triangle OPQ, hypotenuse square equals to base square plus perpendicular square. This we have to solve. So 24 square minus 25 square minus 24 square equals to R square. So 25, this will be A square minus B square. We can write 25 minus 24, 25 plus 24 equals to R square. ओके, इसको सॉल्व करेंगे तो ये आएगा 1 into 49 इक्वल्स टू R स्क्वायर, और R will be equal to root 49, that is equal to 7. Okay, so first option is the correct answer. Is it clear? In figure 10.11, if TP and TQ are two tangents to the circle with center O, so that OPQ is 110, find PTQ. Okay. So actually one easy way of doing this is, this can be assumed as a quadrilateral. Okay. Now tangent and radius are perpendicular. So this is 90 degree. This is 90 degree. Sum of all four angles of a quadrilateral is 360 degree. So 90 plus 90 plus 110 equals to 360. और this and this are actually 180. तो इन दोनों का सम भी 180 होना चाहिए. तो 110 plus something equals to 180. So the
70.
70. Is it clear?
Yes, ma'am.
If tangents, okay, Hardik also got the answer. If tangents P and PB from point P to a circle with center O are inclined to each other at an angle of 80 degree. So there is a external point P. From here there are two tangents. Okay, and its inclination to the circle is, this is 80 degree. Okay, we have to find POA. This is PA, this is PB. Suppose this is center. Okay, so we have to find POA. This angle we have to find. Okay, now when we have seen this theorem, we know that this angle and this angle are equal actually by CPCT. So this angle is 40 degree and the other part is also 40 degree. Okay, so we have to just put angle sum property now. In triangle AOP, 40 plus 90 plus angle POA equals to 180. Because radius and tangent forms 90 degree. So this angle is 90 degree. This angle is 40 degree and we have to find the third angle. So angle POA will be 180 minus 130. That will be equal to 50 degree. So this will be the correct answer. Is it clear? Prove that tangents drawn at the end of a diameter of a circle are parallel. Okay. So basically, suppose AB is diameter. Okay. AB is diameter. We have to prove that the tangents drawn at its endpoints are parallel. Now, if AB is diameter, that means AO and BO are radius. So this angle is 90 degree and this angle is also 90 degree. Okay. So if I name it X and Y, and if this P and Q, so angle OAY equals to angle BOQ equals to 90 degree, and angle OAY plus angle OBQ equals to 180 degree. If co-interior, sum of co-interior angles is 180, then lines are parallel. Okay, therefore it is parallel. Interior angles. These are actually co-interior angles. So if sum of co-interior angles is 180, lines are parallel. Okay. Therefore, tangents will be parallel. Tangents at end of diameter will be parallel. Is it clear? Question 4, you have to draw figure this way, and OAY equals to OBQ 90 degree because AO is radius and XY and PQ are tangents. Okay, so by theorem, radius is perpendicular to the tangent, and this way you have to do this question. Is it clear to everybody?
Yes, ma'am.
Okay. Prove that the perpendicular at the point of the contact to the tangent to a circle passes through center. Okay. So basically, perpendicular at the point of contact to the tangent. Okay. So passes through the center. This we have to prove. Okay. So if XY is tangent, okay, P is point of contact. Okay, so perpendicular to tangent at point of contact will be radius OP. Okay, and radius will always pass through center. So I will start. Question 6. The length of the tangent from a point A at a distance 5 centimeter from the center is 4 centimeter. Find the radius of the circle. So, length of the tangent from a point A. Okay, from a point A, length of the tangent. Okay, so is at distance 5 centimeter. And from the center is 4 centimeter. 1 minute, sorry. Yes, Inalimani, any doubt?
Ma'am, in school we have done question number 5 by taking another center like